Okay, let's begin by moving our inequality over here. Now our goal is to simplify this inequality. Notice what happens if we take our inequality and add 1 over x plus y to both sides. When we do this, we get a much simpler inequality. We can further simplify this by recognizing that the numerator can be factored as follows. And at this point, we have x plus y in both numerator and denominator. As such, we can eliminate these expressions to get x minus y is greater than 0. And finally, if we add y to both sides, we get x is greater than y. So our inequality simplifies to be x is greater than y. So we'll now look for answer choices such that x is greater than y. When we do this, we get the following results. Okay, let's just move our equation down here. Now for our first step, let's eliminate the square root on the left-hand side by squaring both sides of this equation. When we do this, we get x squared minus y squared on the left-hand side, and on the right-hand side we get the following. From here we can subtract x squared from both sides, and at this point we have several options. One option is to first add y squared to both sides, and then add 6xy to both sides. From here we can divide both sides by y to get the following. Okay, let's just move our equation over here. Now our goal is to find the value of x over y. So let's now divide both sides by y, and now we'll divide both sides by 6. And now we're almost done. 10 over 6 simplifies to be 5/3, and 5/3 is equal to approximately 1.66. So now when we go up here and round our answer to the nearest tenth, we get 1.7.
So in general, in the GRE, whenever you see expressions that kind of look ugly and you have to compare them, we know that certainly plugging in numbers would be a lot of work. And the way these questions are written is that there are always some clean way to manipulate these expressions so that it's easier to decide which quantity is greater. So you should always go in that direction. Certainly in some cases you do have to select example values to see what's happening, or if you're not able to manipulate expressions, then you can't really go forward. But that's what I'm going to do in this particular problem. So first thing is, you'll notice this is a minus x. Try to make everything positive. So I'm going to multiply both numerator and denominator by minus 1. So that will become x minus 1 over x. Now you'll see that this piece is the same on both sides. And we also know x is greater than 1. Which means that x minus 1 would be greater than 0. It's a positive number. And when you're comparing two quantities in this column A, column B format, you can divide by a positive number. It's not going to change their relative ranking. So if I divide both sides by x minus 1, column A becomes 1 over y. This is 1 over x. Now again, both x and y are positive. So I can also multiply, or rather in this case, I'm just do the cross multiplication. This is x, this is y. The reason I can do this immediately is that the longer step is you multiply both sides by y. That becomes 1. That becomes y over x. Then I multiply both sides by x. That would become x. This is y. So instead of doing those steps, I just did it in one shot. And the key reason you can do that is because these quantities are positive. So when you're dividing both sides by positive numbers, their relative comparison remains the same. The actual magnitude of the numbers or quantities changes, but their relative comparison remains the same. So we end up with column A being equivalent to x and B equivalent to y. And we're already given that x is greater than y, so we know that quantity A is greater, and the answer is A. Now going back to, if you were not able to do any of this, then you would have to resort to plugging in numbers, and that will be some work. But what I would say is, if you select, let's say, 2, 3 different numbers, so what I would recommend trying, say, 1.03 and 1.01 for x and y, and then perhaps 3 and 2, and maybe some large numbers like 10 and 9. Of course, in all these three cases, you will find the column A to be greater. And at that point, I would say just pick A, even though there is a possibility that that could be the wrong answer. So that's kind of the drawback of when you have to select specific values. You're only sampling a few values, and that's no guarantee that you will get the right answer. But that's the best you can do in that case. So to summarize, the answer here is A.
Okay, let's begin by rewriting our definition here. Now statement 1. When we evaluate this, we get x squared minus xy. We can factor this to be x times x minus y. So the question now is, can this expression ever equal 0? Well, this expression will equal 0 if x equals 0 or x minus y equals 0. Now x can never equal 0 since we're told in the question that x times y is not equal to 0. However, x minus y could equal 0 if x and y are both equal. So this expression could equal 0, so we'll keep track of that here. Now on to the second statement. Well, when we evaluate this, we get the following. We can simplify this, and at this point we can factor out an x times y squared. Now the question is, can this expression ever equal 0? Well, it will equal 0 if this part equals 0 or x minus 1 equals 0. Now we know that this part can never equal 0 since neither x nor y can equal 0. However, this portion, x minus 1, could equal 0 if x equaled 1. So this expression could equal 0. So we'll keep track of that over there. And finally, the last one. When we evaluate this, we get the following. We can now simplify this, and we can simplify it further. The question is now, can negative xy ever equal 0? And the answer here is no. We are told in the question that x times y can never equal 0, so negative xy can never equal 0. So as you can see here then, our answer must be B. Okay, there are several possible approaches here. The fastest approach will be to find the sum of all 16 numbers in our grid. We can do this by adding the sums of the 4 rows. We already know that the sum of these 4 numbers is 3. The sum of these 4 numbers is 6, the sum of these 4 numbers is 9, and the sum of these 4 numbers is 0. When we add them together, we get 18. In other words, the sum of all 16 numbers equals 18. Now look what happens if we add our 4 columns. Since we are adding the same 16 numbers together, the sum must be 18. And now we can solve this for n. We'll first simplify the left-hand side, and from here we see that n equals 8, which means our answer is C.
This is a tricky one concerning functions. We have a composition of functions, f of g of k equals 3. So first of all, let's just figure out where f has an output of 3. I'm just going to call the input u. So u, f of u equals u squared minus 1. When would this equal 3? Well, of course, we'd get u squared equals 4, and we have to be very careful here. We take a square root, and we have to consider both possibilities, u equals positive 2 or u equals negative 2. And so these are the inputs of f that would produce an output of 3. Well, the input of f is the output of g. So if g of k equals either positive 2 or if g of k equals negative 2, then f will have an output of 3. Well, what values of k produce these? Well, g is 1 minus 2k equals 2. 1 minus 2k equals negative 2. Here we solve this, subtract 1 from both sides. Negative 2k equals 1, k equals negative 1/2. Here we solve this one, subtract 1 from both sides. Negative 2k equals negative 3. Divide. Negative 3 divided by negative 2 is positive 3/2. Negative 1/2 is not listed as an answer choice. This would be correct, but it's just not an answer choice. But k equals 3/2 is an answer choice. Answer choice D.
This problem involves counting the number of positive divisors of the positive integer n, where n can be any of these numbers. So F15 means the number of positive divisors of 15. F24 is the number of positive divisors of 24, and so on. And we need to find out which of these statements are true. And there can be more than one right answer. So let's quickly jot down the number of divisors of all these numbers. Here we go. The divisors of 15 are 1, 3, 5 and 15, and therefore F15, that is the number of divisors of 15, is 4. So we have this as 4. Let's get to F24. 24 has 8 divisors, therefore F24 is 8. And likewise F11 is going to be 2 because 11 has got only 2 divisors. So then the question is 4 greater than 8 divided with 2? Well, 8 divided with 2 is 4, and 4 is not greater than 4. 4 is equal to 4. Therefore, this statement is not right. We move on to the second statement. F20 is 1, 2, 3, 4, 5, 6. So we have a 6 here. Is this equal to F25 minus F5? F25 is 1, 2, 3. The positive divisors of 25 being 1, 5 and 25 only. So we have this as 3 minus the number of positive divisors of 5, and that's just 1 and 5, which is 2 positive divisors. So F5 is 2. And certainly 6 is not equal to 3 minus 2. Therefore, this is not right. What about F8? Is it equal to F6? 8 has 4 positive divisors and so does 6. And therefore, F8 is indeed equal to F6. And finally, we have F12, which is 1, 2, 3, 4, 5, 6. So that's a 6. Is that equal to F9 times F3? F9 is 3 because the positive divisors of 9 are 1, 3 and 9 only. So we have this as 3 times F3 is 2. So is 6 equal to 3 times 2? Of course it is. So this one also works. So these are the only two statements that are true.